Good day, everyone. I'm Justin L. Sanggol from BS Ed Math 3A. So today, I will present my final project, task number 1, which is I will show that the set of moves in my geometric model forms a group structure. And my geometric model is called Octa Starlight. And here is the front and the back of our geometric model. And here is the list of the movements. So for rotation, this is our front page of or the front of our geometric model. So let's start with J, which is do nothing. And here is the demonstration. So from original position to original position. The next is U for rotate 45-degree counterclockwise. And here is the demonstration. So from original position, we will rotate 45-degree counterclockwise. The next is rotate 90-degree counterclockwise. And for and from original position, we will rotate 90 degrees counterclockwise. The next is rotate 135-degree counterclockwise. So from original position, we will rotate 135-degree counterclockwise. R for rotate 180-degree counterclockwise. Here is the demonstration. So from original position, we will rotate 180-degree counterclockwise. The next is I, rotate 225-degree counterclockwise. So from original position, we will rotate 225-degree counterclockwise. And S, for rotate 270-degree counterclockwise. Here is the demonstration. So from original position, we will rotate 270-degree counterclockwise. And lastly, for rotation, rotate 315-degree counterclockwise. And here is the demonstration. From original position, we will rotate it to 315-degree counterclockwise. So next is our movements of flipping, which is the back area of our geometric model. So without further ado, let's get started to demonstrate the movements. So L for flip vertically. So from J to R, we will flip it vertically. The next is O, flip between left diagonal and vertical axis. And here is the demonstration. The next one is V, which is flip about left diagonal. And here is the demonstration. The next one is E, which is flip between left diagonal and horizontal axis. And here is the demonstration. The next one is M, which is flip horizontally. And here is the demonstration. The next one is A, which is flip between right diagonal and horizontal axis. And here is the demonstration. The next one is C, which is flip about right diagonal. And here is the demonstration. The next one is H, which is flip between right diagonal and vertical axis. And here is the demonstration. So now that we already know how to flip or rotate our geometric model, let's now try to operate some elements for demonstration. So N star C is equal to I. And here is the demonstration. So we will rotate it U, IN, which is the 90 degrees counterclockwise, and C for rotate 135-degree counterclockwise. So we will get I. Next example is R star N. So here is the demonstration. So we will rotate it R, which is 180-degree counterclockwise, and we will add the S, which is rotate 270-degree counterclockwise, and we will get the N, which is the answer. Next is V star U is equal to E. So now here is the demonstration. So first is V, which is flip about left diagonal, and U, which is rotate 45-degree counterclockwise, we will get E. The next is L star M is equal to R. And here is the demonstration. So we will flip vertically. After that, M, which is we will flip horizontally. We will get R. So after we do the operations, this is the possible outcomes or possible combination that we will get. And so now, let's show that octa starlight forms a group structure. And here are the conditions for group structure. First, A, which is it is binary operation, and G1, which is it is associative. G2, it has identity element. G3, there exists an inverse element for all. So now, let's first check if it has it or if it is a binary operation. So this is our table. So let's check if it is binary or not. First question is it well defined? Yet, the answer is yes, because since each move produces exactly one or unique result when we operate an element, therefore it is well defined. The second question is it closed? So since all the elements in the group of the table are members of the original set, the operation is closed under the given set. So it is a binary structure. Check. The second condition is check for associativity. So to check for associativity, first we will rotate this original table into 180 degrees. So here is the after rotation of 180 degrees. Notice that it is not equal to original table, but after we will interchange something, or rather in interchange column rather to make it an equal to the original table. So first, we will interchange column T and column L, which is the green colored text. After that, we will interchange column A and column O, which is the blue text colors. The next one is we will interchange column M to column V, which is the violet colors. The next one is we will interchange column D and column U, which is the color yellow letters. The next one is we will interchange S to column S to column N, which is the blue letters. The next is we will interchange column I to column C. And after interchanging, we can now compare the original table to the rotated 180 degrees. As you can see here, the original table and the 180 degrees rotated table is equal. Meaning, since after rotating the table to 180 degrees and interchanging columns, we still got the same result like the original table, thus it is associative. And the table satisfy the associativity condition. So for associativity, check. Now let's move on to check for identity element. So as you can see from our original table to the second column, when we operate the first column to J, we will get the exactly or the identity itself. And for the row, for the second row, when we operate the second row to the first row, we will get the identity itself. Meaning, here in the table, J is our identity element. So to check if it is true, let's operate the element to J. So J star J is equal to J, which is the element itself. U star J is equal to U, which is the identity itself. N star J is equal to N. C star J is C. R star J is equal to R. I star J is equal to I. S star J is equal to S. D star J is equal to D, which is the identity itself. And L star J is equal to L. O star J is equal to O. V star J is equal to V. E star J is equal to A. M star J is equal to M. A star J is equal to A, which is the identity itself, until to H star J is equal to H. Meaning, J is our identity element in our geometric model. So we have the identity element, which is check. So the third condition, or the fourth condition rather, there exists inverse elements for all. So this is also our original table. So here, so for example, the row I and the column C, when we operate them, is they will equal to J. Because when we are getting inverse element, if we operate two elements to each other, we need to get, or the result need to be the identity. So given, para mas madali, titignan mo lang sa table yung mga identity element. So kagaya yan, si J nasa row siya ng I and column niya ng column na C. Meaning, the inverse element of I is C because it results J, which is the identity. Just like the row L and the column L, which is when we operate them is equal to J itself. And so meaning the inverse element of row L is the column L. So now to check if it is true, let's operate them individually. U star D is equal to J, which is the identity element. N star S is equal to J. C star I is equal to J. R star R is equal to J. I star C is equal to J. S star N is equal to J. D star U is equal to J. And so on to H star H is equal to J. So meaning, here are the list of the inverse element. So all of the elements has an inverse element, meaning we satisfy the fourth condition. So the condition for a group structure: A, binary operation, check. G1, it is associative, check. G2, it has identity element, check. G3, it has inverse for all, check. Since the table satisfy the binary operation, closure and well-defined, it is closed because the results are in the set, and also well-defined because results are unique. It has also associativity, identity element, and inverse element. Therefore, this table, or the our geometric model, which is Octa Starlight, is a group structure. So that's all for today. Thank you.